So today we will talk about distributed system and about energy efficiency. Actually, the main part of our lecture will be connected with how to process high load to spend less electricity, less computational resources, and so on. Um, um, I think we start talk about distributed system. So I just remind some points, and then we will go forward. So uh, according to distributed system, so as we understand from high loaded from tasks which solve high-loaded system infrastructure for high-loaded system. Also, we understand that we need some huge resources or lots of resources for computational resources for processing such kind of requests. And according to distributed system, mainly it is about some how to divide the tasks and how to use how to use computational resources when we know that our task need how to say our task should think that it works with uh, single resources or single node, computational node. And in this case, exactly we need this technology of distributed system because I think we talk about it's some slides from previous lecture. It's all together. So what I want to say. So we need when we talked about, for example, containers or something else, some with virtual machine and so on, it was computational node as a processing node for request. The request is sent to this application, and applications process that request. But sometimes we have no we have huge tasks. What does it mean? For sure, when we have huge task and we can divide it into smaller one, it allows us to uh, send this small task to different containers or something else. In case with actually it's also distributed system because we have some group of microservices, for example, who solve some tasks, and these tasks no, can be processed by single node. In case distributed, in case when we have huge task or we need some platform, some computational platform for processing for our system, for processing our requests of our system or tasks of our system. We need such kind of middleware. So middleware, some no, it's application actually who interact with the local operation system, and when we process application, small or huge one, anyway, this application communicate with this middleware and for solving all tasks. So it's uh, instrument for I don't remember in English представление. Да? So we we connect or we group all computational resources into one interface, and with this interface, application works. So you can read some of this in this by these links and so on. What we wait from a distributed system, or how it um, how it should work, and what should be hidden from users to think that it's just a computational system. For this, first of all, should be organized access. So each user should think that that it works alone, for example, or that nobody will have access for its objects. Then for users, it doesn't matter where is computational resources located. As usually, we need some. So it doesn't matter where it is placed. It's just influence have influence in maybe some delays or something like this. But delays can be also in computer which be very close to you. Then relocation we should be hidden, so nobody should know that something wrong or something that some nodes or some tasks were relocated from one node to another computational node. Replication also, so to be sure that all will be saved, we have to replicate all tasks on the resources. I think during this course we lots of times said about replication, so you good understand what does it mean, and also this is also needed for distributed systems. Concurrency, it means that for end users, we shouldn't know how the computational resources shared between tasks, and is it enough resources for this subscriber or that subscriber, and so on. And so also failures should be hidden to not and system should have a mechanism for recover all objects. Its main if you look at this in this table, you can find some connectivity, some common things with mm, no other system about what we say, because it's common things for high-loaded system. We need to provide service in such level, in such uh, um, no, with such possibilities in any system. For example, for infrastructure of Kubernetes, in Kubernetes or in other distributed systems. So it's different layers. But when I spoke about no, your mom mind layers, so in no OC model, so we different tasks is solved in different layers. For sure, it's not this. No, it's the same idea, but another realization because transport, no, some protocols or telecom protocols, it's from another world. But anyway, so we have for high loaded system from one side we have services who create this load. From other side we have different instruments to organize infrastructure. It can be containers, it can be some virtual machine or something like this. It's another. It's just computational nodes. According to idea of distributed system is how to propose how to use that computational nodes as a one system. So it's another layer. So for sure, when we talk about some local operational system one, operation system two, it can be placed on some virtual machine. So it can be virtual machine. But distributed no, this middleware is another layer where we solve task to coordinate coordinate and for all resources and show them as a single one. Okay, this something about these things about dependability, uh, for availability, reliability, safety, maintainability. So it's main also characteristics of this system to provide the service. Scalability for sure, because any we can't use unscalable infrastructure for high loaded system. It's in this case it will not solve our problems because scale of number of our requests can be changed very fast. So scalability is very necessary things. So we have some have to talk about size scalability, geographical scalability, and administrative scalability, because we need instruments how to manage the system when it will grow and will become bigger and so on. What is the bottleneck? What is the place where we can have problem? First of all, it's computational capacity limited by CPU. From other one side, so it's exactly physical resources, storage capacity, including EO transfer rate. It means how this computational resources, how these channels works, and the network between user and between user and centralized service. So we for sure our telecom network, if it is used for transmission, it's also another system, but it can be a bottleneck if we will not organize this as it needed. We also talked about sharing of memory or not sharing memory. This different uh, different kind of interconnection for distributed system for distributed systems, and um, So, what how it works? It works that we different kind of sharing is used for different uh, tasks, and therefore when um, we have tasks who need more memory or some. So in this case, one processor can use all memory for it works. In this case, it's only fixed number of resources. Therefore, depending on so in um, architecture, this architecture should be chosen for depending on kind of resources. According to h- how it works and where it is used. We talked about, I think we talked about clusters. What does it mean when we think about cluster? We think that it's some huge computer with some lots of resources and so on. And therefore, these ideas of distributed computing, it's also shared with to classic computing because we need some blocks of some processors, and we have some memory and some managed nodes. So some physical nodes which is used for processing. Management knows how to coordinate it. It can be so how to coordinate work of this no, huge computer with lots of elements for processing the requests. So uh, uh, we this cluster computing have to have a high degree of transparency provided by allowing processor to dynamically and primitively migrate between the nodes. So how it should be. It should be on one side. It is independent nodes which can be replaced or which can be work or not something to work on not together and so on. But anyway, in uh, uh, in for end user or other applications should think that it is the same one. It's a one computational process. Therefore it's also about a distributed system. According to the rules of transaction processing monitoring of distributed system. So we here we can see that for client who send request to this distributed system, which it thing. So clients work with the system, no processing system, yes. So it just communicate with this TP monitor, and this TP transaction monitor is choose which server will process this request, and actually it's some kind of balancer. We talked about some elements of pool. You remember push pull concept how to processing this service. So for sure now we have lots of different technologies or principles to balance this load to balance to choose which server or which computational node will choose the will choose the uh, will be chosen for processing the request. So вибачте. So come back. And also uh, what when we when we have different client applications and different services, so this communicational middleware organize this processing or this load balancing of the task, how to process the request. So remote procedure calls application completed can effectively send request to application. And actually, it's different methods of um, different methods of client application communication between client application and server side application. So um, remote procedure call. So its application component can effectively send the request to another application component by doing local procedure call. Remote method invocation is essentially the same of expect that it rates the objects indeed of the function. I will not read all of this, but you can look through and see how it works and also message oriented middleware. I think it's one of kind of when clients send message to communicate the middleware and receive response uh, for the processing. So something like this. Okay, do you have question according to distributed system? For sure, this is very huge. No, actually, all our course is about each lecture can be described. Can be um, one course to see. I just want to uh, propose you a whole picture of these systems. And for sure, there is lots of technologies, lots of specific for this. And for example, in ETS, we have in our institute, we have some courses with with the distributed computing system. So it's lots of things can be done in this direction. Next topic is energy efficiency processing. And what does it mean? When we talk about energy efficiency, it's very important how many kilobytes or kilobytes, kilowatt, sorry, was used for this or that computational task. And therefore, when we talk about high-loaded system, so we can't leave this question alone, because when we no, I will not speak about energy troubles in Ukraine now. So, but even if we have enough electricity, we should save it, uh, at least for less payment for this, because you know, for example, it was some for example, I don't know, 5 years ago, maybe 6 years ago, Lifecell sent us no, so s- they organize laboratory where they put how to say controller of base station. They will this one was not used for in it was quite old for them, and then therefore they give it for us for training, for using, for understanding how it works and so on. And it was a really big problem for our faculty, for our institute, because mm, mm, first months they didn't count how many electricity it is used for, and it was some, I don't know, some unreal numbers, 10,000 or something like this. 8 years ago, it was too many, too much money for just controller, which just for training without any. Um, so it was too expensive for our institute. And after that, we did we didn't turn it on. No, I think it will. They turn it on the some labs or something like this. But anyway, it was very too expensive. Why it was too expensive? Because no, there wasn't energy efficiency elements for energy efficiency control for this request. So, so according to it's just about energy efficiency. What about I want to say here? The functioning of server cluster, how to coordinate operation. It's not, you see, I speak about one thing and slides is about other things. I think all these tasks should be done by server cluster, and maybe for mhm, okay, for example, coordinating operation of all services, resolution of conflicts, server cluster configuration, workload distribution or scheduling between cluster nodes, if necessary, cluster scaling to adapt the amount of resources to need of workload processing, and monitoring of hardware and software environment. Its main functions, I think it is clear. For this, also in this slide, we speak about, we can see different topology for connection of the nodes of in the cluster or something, how to organize this cluster topology to provide fast connection for this. And from one side, it is one connection. but from other side, it is we have more switches for to be sure that this system will not fail or when one switch will be broken. Okay. When so before we will talk about energy efficiency exactly, we should speak about service level agreement. Why it is so important, and why we should think about this before energy efficiency, energy consumption. Because each subscriber want to receive enough service level for according to its contract. So service level agreement, it is some points which is fixed on the contract between subscriber and service company to provide such a level of internet or such level of of the service. For sure, I don't know. Did you uh, have have you seen such elements? But for example, when you pay for some gigabyte for internet, and then after this gigabytes, for example, per day, it's over. After that, you receive very slow speed of the service. So you can service level is changed, and therefore for changing this situation, you have to pay, or you have to change your service level agreement. So service level agreement, it is what you receive, uh, which detailed plan of the service. And the main parameters is system availability and as a percentage of operating time. Next one is time maximum response time to request. Also, X, for example, is percentage of the request which is response time to request more than X second. Why we need this SLA? Why we need these parameters? Because we have to so the system about what we speak, it is very flexible. You have so you can manage lots of things, and therefore for sure to propose the service, you want to provider want to use its channels or its equipment as good as much as possible, and the upper bound of this level of usage is uh, is uh, uh, this SLA, because we always should check is any user have received such level of service as he paid. And therefore, we to speak about this percentage, this availability, and so on. Procedure for responding to problems, emergency situation. So also this points also fixed in SLA, so service level agreement. Therefore, these parameters is fixed when you speak about, for example, no, I propose example with telecom company, but from other side, it is from other side, it is uh, also for example, for some no, when you use some cloud services or some other resources, no, when computational resources as a service, yes, you used for this. Therefore, you shouldn't propose this. You shouldn't receive worse service than you pay. Um, from what parameter, from what is the components of one of the delay of the SLA parameters? For example, maximum response time. We should understand that from it contains four different elements. First, it's a delay in the internet. On this one, it's maximum is 3 seconds. Then response time of application. So, for example, 3 seconds. It's for something for transaction response time. System processing. It can be CPU utilization, memory utilization. So how exactly computational resources is used. And then network. Also 2 seconds. How the network parameters is used. And therefore, all delays is uh, added to the one max SLA. So it is one of the parameters of SLA. Then, according to characteristic of the workload processing. Here you can see some parameters like RAM like storage value, like performance of each node. Why we talk about this? Because this depending on the these parameters, our request or request of subscriber can be processed faster or slowly, more slowly, and anyway. And what is the interesting parameter? It's function P. It's PG. It's a nodes energy consumption model. How it is used? It depends on. It was developed that depending on how on usage of CPU and other computational resources, the function is not linear. For example, it's actually, I don't know, is it here? No, I just look. It's like it's not line. It is some line лінійна. Це не лінійна функція, це така собі зростаюча так от функція. And this function will be different for different tasks, different for different tasks, for different ну, elements of computational resources, because as we see, when we talk about cluster, it's one function, or when we talk about computer, it's another function, and so on. What is idea is calculate where or is how to plan the resources for how to plan the resources or how to plan the task, because our instrument is load balancer, how to balance the tasks uh, to use less energy, and therefore we need this function. Also, we need such parameters: compute performance of node, some number of computer cores of the node, so we something like this, and therefore we think that some nodes can be alive, so it works, or it can be waiting for, or it can be turn off. And depending on our потребности, necessity, we use, so we not used, but we we use this we we can what we can do, we can turn off the node, or you can put it in idling mode to save energy. So save energy is the main point for our main task for our system. What next? Workload processing in a distributed system. Um, so, what depending on organization of our processing, no, this process, we can what elements process this request. For example, we have input workload, then some workload. So actually it's nodes who process the request. But for main for saving more energy, for manageability. You remember today we talked about that some nodes, some resources is used for management, for for providing manageability of the system. For this management, we need monitoring, resource planning, scheduling, and also we should organize, so we should think about fault tolerance. So after all these elements is work together to manage the processes which is processed in workloaded in this nodes. The unit of input workload is a computational job. It's different names of the same thing, but why it is exactly computational job it calls? Because each computational job, it's how to say, use some resources, for example, and some some integrated resources. Maybe we'll talk here about this, not this again later. So this computational job has its own requirements to the system. How many resources it is needed for voice processing, and so on. And when we have when we calculate our task as a computational job, we can manage the resources on all the system depending on our possibilities. Okay. Workloading processing distributed system. The monitoring subsystem monitors the available rate of computational workload. I think I will not read this anyway. So we need some monitoring to understand is it enough or not? Is it how many resources we have without you staying without usage, because we have to turn on or turn off or hold some resources for process for using less resources. According to resources planning, you can no, actually it's two how to say concept of scaling and resource planning. You can vertical scale when or horizontal scale. Vertical scale, it's when you use more and more and more computational nodes and how to organize, no, to for growing your system. But horizontal scaling, when you add new and new resources to your node, so you didn't change number of resources, but you change number of uh, you change number of you didn't change number of nodes, but you change number of resources for each node. Also, according to scheduling, it means that no, sometimes we don't know what will happen, and for this, when we don't know what will happen, we use short planning. But for example, each day, from Monday to Friday, we have working hours, for example, 9 or 8, or so some depending on which task you solve. But anyway, for example, if your processing is coffee machine, so maybe from 8 to 9 it will be more coffee will be sold connecting with, for example, 11 a.m. So therefore, we can schedule how many resources we need in different period of time or during the day, and we can use this for our energy efficiency consumption. According to the workloading scheduling processes, each computational job is characterized by its by such parameters. First, it is maximum processing time or timeout, time period from the moment the job has been accepted to provide processing, and which it must be completed. If the job has not been successfully processing, when our time over more than its time max, it is removed from the system. The minimum amount of resources for processing job, because for sure we can for example, depending on the on the task, job as it's called here, we can process so we can um, actually number of resources and no you know it's like okay when you have for example boats and you have a queue of the people who comes to the river and sit on the boat and in this case it's some fixed number of resources, so some fixed number of boards to processing the request. But when you use shared resources or something like this for different tasks, and in this case you can say that some about minimal amount of resources for processing the request about maximum, or you can not choose this maximum. But anyway, so in what kind of resources? How many RAM you need? How many CPU cores you require is required for your tasks? Then minimum required volume of data storage, job priority also, because it's all this is has influence on the processing of the request. So I think I will speak. Maybe you have question to me.
No, everything's fine.
It's quite okay. It's quite clear. Okay. I think as I told you, we today we work 2 hours, and it's our no how to say the last lecture in this semester, and I think I will in 5 minutes I will have I will need 5 minutes to stop talking for a little bit because and 5 minutes will be break and then we continue. Okay.
Yes,
So
okay.
sorry, it's outside of my car. Okay. What other thing we efficiency indicators to and criteria to workloading processing. Common performance indicators that determined by SLA, so which should be provided during the processing. So it's maximum responsible time, distributed system availability percentage, and also energy efficiency of distributed systems. So uh, um, so we have to provide service not upper bound, it's верхняя, no, not less than this bound for our customer. Next one is the basic concept of energy efficiency. Actually, such definitions is on the some standards or some recommendations. So what does it mean for power consumption? So I talked about this lots of times, but here we can see definition. So power consumption defines the work performance by the system per the unit time. So energy transmitted per time unit. So it's also you can see it here, where R is total work performance of by the system, double the energy consumed of the by the system. So how many energy was used for in the time period. Power consumption characterizes a speed of work performance or speed of energy conversion, respectively. How it was. There is a scale quantity measuring of in watts in the same system. So it's в ваттах відраховується. So anyway, so amount of energy consumed energy. So our W is here. Is it? Process. W here. It is total amount of work performance by system over the time period T. So consumed power multiply on time period under consideration. The difference between power consumption and consumed energy is as significant or in the context of energy efficiency. It is reduction of power consumption does not always lead on the total consumed energy. So difference is how many energy we used and how many energy we was used for task and how many energy was used in general. Okay, next one. Payload. Payload, it means how effectively we use our resources. So what load is useful or paid, and what load is not paid. So all this we need for understanding, for comparing, and for comparing our resource usage from one side and our no energy consumption model at last. So amount of payload V, small one, is a general case is determined by the number of elementary floating point operators that must be performed by the system. It means it calls flop, floating point of point operation. Actually, it's quite spread used definition because it means that how many job you do on with usage these resources. So flops, it's number of resources for one small task. It can be. So you can, so all tasks, tasks can be counted as as a number of flops that can be no, so flops and floating point operation for really computational job. So for counting this computational job. Okay, we know what does it mean flop. So it's job on on these operations. Yes. So energy efficiency of data processing. It is amount of payload V processed by the system or some server cluster consisting of n nodes when consuming the amount of the energy W. So each node, it's very easy. Node is used V, big V, energy. This payload was processed on group of these servers. Therefore, we have some underline. So the higher was this value is more energy efficiency of the system, and it can handle the more workload and with less energy. So as much as more works we will do, then and with using less energy, in this case we can talk about energy consumption in general. Okay. Indicators of distributed data processing of the energy. Data processing performance or capacity. It is amount of payload divided to time unit. So processing time, how many flops we did during the time 10. Actually, it's I think maybe you will not remind all of this, but you should know that for when you plan and when you organize the system for high-loaded processing, you have to plan also this workload for the system and how to make some calculation before the processing. So because depending on main idea of this is that we want to add this element of system task processing to load balancer, because depending of load balancing we can manage the number of we can manage the load of the resources now, and the load, as I told you, load of the resources has direct influence on number of on energy usage. So therefore, okay, according to system availability, it's in percentages 1 minus lost of this. From other side, other efficiency criteria is K. K is we need to maximize multiplication of this energy consumption in to payload. You can see here. From one side, it's payload or divided on the resources which it was used for. From other side, payload on the time, and this multiplication we should maximize. So we want to maximize our energy efficiency. With subject to it means that pay available should be more than pay available SLA. I told you that SLA we shouldn't propose the quality of the service less than was fixed in SLA, and therefore we have such formula. According to energy scalability of the system component. We need, we can provide such technologies as dynamic voltage scale, dynamic frequency scaling, combined approach to dynamically voltage and frequency scaling. So all this is to should be organized to propose energy efficiency service. According to instruments, maybe I talked about 5 minutes. Let's stop, break on a few minutes to, okay? If you're not, a few minutes, 2 minutes break. Thank you.
Okay.
Sorry, I speak with you. Okay. Uh, so, according to these methods, first of all, so power management methods divided into two main branches: static power management and dynamic power management. So static power management can be provided in CPU level or in system level. Exactly in CPU level, can be on side of register set optimization, from other side instruction set optimization. So it's according to static management. Dynamic power management has more possibilities. Also, it can power scalable components from one side and power scalable resources management. So scalable components and scalable resources. According to scalable components, it can be also three branches: power scalable processors, power scalable storage, and power scalable memories. Also, processor can also different technologies or different methods. It's DVS, DFS, no different one. The same one according to storage. You can use storage with caching, with grouping, with caching, grouping, replications. So also this method can what does it mean power management? It means that different scenarios propose no use different number of resources and that it's interesting. Next one is power management, scalable resources. Okay, when we how we can manage resources? We can have reactive management, proactive management, and hybrid management. It means that reactive management propose to solve problem when as fast as they are organized. Proactive is find solution and prevent the problems. So to solve it. And hybrid one, it's hybrid one. And also scenario can be centralized or decentralized for the system. So as you can see, depending on scenario of usage different resources, um, we can use different methods, and also it can save energy for us. So next one is just according to horizontal scaling uh, um, and consolidation. No, according to horizontal scaling, I said it is when we add the resources for the system, and mm, uh, in this case, we can provide the horizontal scaling. Belong the class of it is it's a class of dynamic approaches. So to system resource management, and the main idea uh, to consolidate the workload processing on the minimum amount of the resources in order to move some resources from the active state, avoiding the idling. It means that we can always change number of resources. When you talk about some cluster or something, some physical resources, some group of physical machine or distributed system, we can some nodes can be holded or can be turned off or something like this to save energy. So main idea to work only that resources should work which is needed exactly in this moment. It's main idea. And also environment with hardware-based logical pooling, resource of resources represented so-called virtual machines. So we can change number of virtual machine, or we can turn off some cluster units for saving energy. According to virtual machine, why it is necessary to solve? Because because we uh, so any load of the computer is any load of the computer is it's energy э, как там, пожиратели энергии. Отже, чим as less we use as less we use resources, as less we м, as less we use the resources, as less we process task in the moment, as less we use energy resources. Therefore, uh, virtual machine consolidation algorithm solves for subtasks. Which task? First is deciding on insufficient load of the system node. In order to further move all virtual machine from it and divide and drive the node to sleep mode. So it all these technologies is work together from one side. From other side, it allows us flexible computational nodes who can move and then hardware can be turned off. Deciding of the excessive load of the node in order to transfer part of virtual machine from one computational node to another. And to balance this computing performance. Third one is selection of the virtual machine for a relocation of the overloaded nodes from the whole set of virtual machine on the node. So all this is node. Placement of virtual machine selected for relocation to other active or reactive node. So placement, removing, replacement. So we can operate this with virtual machines for main for better energy usage. So it's virtual machine consolidation can reduce total energy consumption by up to 30 percent with limited impact of computing performance. It's also all about horizontal scaling. Next one, analysis of energy efficiency management methods. What is the main idea also to schedule the work of schedule work of the cluster of the task and a plan which one should work, which one should be wait. So for according to clustering, cluster nodes using hierarchical and k-means cluster algorithm. The workload level classification in the in server cluster of low, medium, and high based on workload statistic. So should um, so this is about scheduling which cluster node should be is planned to turn off, which is not, and also this one. So we have to optimize usage of these resources. Other method is after-pilot approaches used by Google. Just a minute, I will see how many slides we have and where it is. Okay, not so much. Not so much. Okay, so to solve is reduce so what is the main after-pilot approach of used by Google to solve it to reduce so-called slack between maximum possible and actual usage of available resources, combining horizontal and vertical scaling. As I told you, vertical scaling when you use more computational nodes. So horizontal scaling when you use more resources for each node, and vertical is more nodes. Using the Born workload scheduler, it is possible to adjust the requirements of the job for minimum computational resources. After pilot, allows matching the computational job and the amount of resources for their processing as accuracy as possible, which reduce the equipment idling by avoiding accessory resource reservation. So it is so you can see that uh, it's not something new. It's this exactly the necessary thing to plan the infrastructure resources as for reducing the energy usage. Okay, energy was also, you can see here the energy workload scheduling. Um, hmm, so actually this scheduling propose to schedule processing processes to what they propose. The main task of workload scheduling is to establish correspondence between the available data processing resources and workload of requires processing. So what we already process and what we waiting for this processing. Also, the simplest approach is first come, first out, first served, FIFO, first in, first out. Algorithm distributed jobs according to their order in the queue. For example, round robin algorithm, it's determines some tasks weights, and it's look at different points of the resource. So takes look at the queue and choose exactly by the round the tasks from different queues to process depending on the resources necessary. Okay. Cooperative two-tier energy shadowing. In local level, resources are distributed of one server between jobs, so that each job received the minimum computational resources required to process it. Resources left after such allocation are distributed among all jobs. It's from one side. In global level, jobs are distributed among cluster service according to one of the technical distributed in paper: predictive energy, predictive total time, and other. This techniques is at the same time takes into account the parameter of energy efficiency and performance without jobs scheduling. So it means that take into account job um, necessary of the resources and how it is how it is influence on the whole picture of energy efficiency. What something here is not good, just in few minutes I will make it less. Backfill strategy. It is about backfill strategy It is about how to um, plan the tasks to use CPU depending, no, more effectively to say. So it is how to process the jobs to, you see, uh, no, more effectively to put some. So maybe I will read it. So the main idea of backfill strategy is to densely fill free resources, uh, arbitrary queuing tasks for each which or the amount of these resources is sufficient. So first, scheduler reserve resources for big job, computational job in the queue. It calculates the start time of the job, taking into account the release of necessary resource in the system. Actually, very one of the most important question on this is how many time we need for how many time we need for this solution, for finding this solution. Because if we have real-time requests, it means that delay is very important. Therefore, this scheduler should work very quickly and so tasks should be marked how many resources it needed and so on. So it's very interesting and complicated task. According to two-level model of the request processing, what here we can speak about. First of all, it's a common picture of the scheduler. So we have some queue where we receive request with some densities. It means how many requests in time slot. Then main scheduler send the request into different queues, but this queues is monitored by system of monitoring and send information to balance controller. And balance controller work with main scheduler and so to upgrade to propose to the algorithms of main scheduler. So this idea is quite something like backlink. But each server has, for example, its own queue from one side. From other side, it has its own computational resources, K0, K0, K1, and so on. And therefore, this computational nodes also has some functions. It's mu, it's density of processing, So it's something we have such system. You can see here that querying system it's MM1K. It means that how to what kind of internet what kind of um, kind of flow density was is processed by this. So poison input, poison output is розподілення, нормальний розподіл для вхідного навантаження і нормальний розподіл для навантаження, ну, вибачте, не нормальний, пасоновський. Розподіл для входу, пасоновський розподіл для часу обслуговування в кожному з цих елементів кластеру. Якісь. Окей. Here we can see some calculation where we some calculation. It's how to um, how to count the density of processing this request. How many requests should be sent. M group of requests is of not ordinary poison team, so it's group of requests, and this request should be float of the lost request. So because when request was in the queue to time more than it's possible, more than it was fixed in SLA, then this request can be loosened. Can be lost. Can be loose. And so number of cores and outgoing stream of the server, so how all task was processed. This function is that number of resources said should be less than it is needed for processing all these things. So what it's detailed construction picture how it works. Okay, anyway, software-based energy consumption model definition. The main components of the computing system power consumption of which is taken into account is CPU, GPU, RAM elements, element of persistent memory, display memory if it's available. So what does it mean? It means that depending on organizing computational processes of the balancing of the request, we can reduce the energy consumption of the request more than on 30%. And main idea is turn off the not used, turn off the nodes which is not used. Software-based energy consumption, the total the total power consumption this of the computing nodes of each considered level of CPU from 0 to 100 calculated by formula. So it's depending on power consumption of each of these edit ones. It is components who use energy and which this work of these components is necessary for processing the tasks. And here we can see CPU 1%, 0%, 1, 2, up to 100. And these points is different, and we can we have to know this number, this number of this. As a result, for the function of power consumption, P F CPU is dependence of power consumption of group of computing node for degree of CPU load. Remember, when I just start to talk about energy efficiency, I talk about such not linear dependency. It's some formula, and this is formula of how to calculate this function dependency. Function of workload, function on energy necessary depending of CPU CPU load from 1%, no, 0% to 100%. And here you can see this picture of these lines. Power is green one, and energy efficiency is red one. So depending on the percent utilization of the resources, we can choose the main field or main when we can use, for example, 20%. Yes, it's 80% here is power usage from one side and percent of CPU utilization. But when we this one, for example, 70% gives us 50% utilization. So it means that we can balance the request depending on on this function, and it helps us to. So this function is exactly can be balance controller is used. This function can be used on this block to manage better manage better the request to find better number of requests for this and network service architecture. I think it's okay. This is example that it means that here we can see the nodes, but and also telecom network which is connected these nodes. I think it's enough for you for today, and I hope that you understand main points according to energy consumption, because here it's okay. Here's its workload, how it is used for. It depends on different criteria, different elements about the network, and so we can use this function. We know this mutes. It's number of parameter of energy process. How many requests was processed in a time unit in GT on eth branch in g's node. And so eta gita, it's a number of the task E assigned to SG. So so energy consumption is how many uh, how so how many tasks is processed on the point how many tasks E is number of the task, G is number of node where it was processed, and so in this way we can calculate the energy consumption. Current system also, how to manage it, and the main proposition, okay, it's enough. To ensure the functioning of the service cluster, the system runs distributed data processing software, which is responsible for coordinated operation of all services, resolution of conflicts, server cluster reconfiguration, workload distribution, if necessary, cluster scaling, to adapt the amount of the resources to need of workload processing, and monitoring of hardware and software environment. So we can look through, we have possibility to look through this problem of energy efficiency, and now you know, you can, no, you know about this problem as a problem, energy efficiency. From one side, you know that the energy efficiency is dependent um, on the how request is processed on the servers. No, so depends on load balancing and depends on whole organization of the system. Do you have question to me? I think it's all, that's all what I want to say about you about our topic about high load system. Do you have question? Okay, if you don't, I think next time we will not there will be not lecture. It's over. Today I will send you third test. You complete it. Then um count your marks and send to Marina. I think if you want to rise, ну, поднять your mark, you can send me the labs which I submitted to our channel, so you can do this, and then this gives you additional score. Okay, do you have question?
Can I ask,
Yes, you can, even in Ukraine, if you wish.
яку, дивіться, це виходить напрямок DevOps?
Да. І потужно. Да. Ну, насправді тут якби
А що, ну, що це саме буде? Це Cloud Engineering, DevOps чи там, ну,
що ви маєте на увазі? Ну, DevOps – це набір технологій, які що ви маєте на увазі під словом? Це DevOps чи не DevOps? Це підхід до, ну, це розкриття теми високонавантажних систем. Да, це в тому числі використовується в DevOps, ну, DevOps цими побудовою систем з готових рішень. Да, це цим також займаються. Да. Той самий Kubernetes і так далі. Тобто це все використовується в DevOps. Ну, DevOps використовуються.
ні, я просто не знаю, чи є саме якась професія, яка окремо від цього йде, саме розрахована на ось це.
Ну, я не можу вам відповісти, що це прямо аж професійна якийсь напрямок, але те, що на сьогоднішній день проблема організації обчислювальних ресурсів, групи віртуальних машин, ну, це програмування, значить, це професія окремо. Ну, то, що і DevOps цим також займаються. Тобто просто це якась така узагальнена картинка без конкретики. Конкретику. Ну, розумієте, в лекціях, якщо я не знаю, чи я всі виклала, чи я зараз подивлюся, там є купа різних посилань на різні технології, і ми же просто по них прошлись як галопом по Європам, і, ну, грубо говоря, без конкретики. А так, для того, щоб працювати в цьому напрямку, треба виконувати практичні завдання. Розумієте? Це загальна картина.
Так. Мгм.
Ну, я хочу сказати, що якщо у нас є викладач Нік Олексєєв, він якраз таки DevOps, і він якраз кубернетісом займається і прочими організацією інфраструктури для різних завдань. Ну, тобто, ну, такими ж штуками різними. Ви можете у нього запитати, в нього у вас, якщо є пари, а чим він займається. От, ну, я відповіла на ваше запитання?
Так, добре, дякую. Просто чисто загально так.
Добре. Ще є запитання?
Так, є ще одне запитання.
Угу, кажіть.
Скажіть, будь ласка, а от всі такі контрольні роботи, які ми пишемо, вони в сумі будуть складати яку кількість балів? 100 чи менше?
Да, дивіться, там справа в тому, що бали, ну там десь по 20 балів за цю контрольну, так? Потім, я не пам'ятаю, якось я так рахувала минулого разу, множила на коефіцієнт, скоріше за все. Тобто, якщо у вас 20 балів, ну, в контрольній 20 питань. Тобто ви написали 3 контрольні, це 60 балів. Множимо до того, щоб максимум це 100 балів. Да? Зрозуміло, що я маю на увазі. Я зараз не
Так,
пам'ятаю
так.
коефіцієнт. Ну, для того, щоб тобто, 60 балів це. Я напишу, я зараз вже поганенько соображаю, зараз хвилинку я скажу точно. Так, я тут екран закрила, так, це зупиняю.